Muted.
Good morning, everyone. Welcome to Baroque Tools webinar series. We're going to go ahead and get started in about 5 minutes. You're in the right place. Good morning, everyone. Welcome to Baroque Tools webinar series featuring the total cost of ownership for the Oak Triumph Hairpin bender. We're going to go ahead and get started here in just a little bit. We'll let others trickle in, and we'll get started. Good morning, everyone. Welcome to Baroque Tools' third installment of the Oak webinar series. We are excited to have Brian McConnell, President of Baroque Tool, here with us today. My name is Jason Halling, and I am the Manager of Business Development and Marketing at Baroque Tool, and I will be moderating today's event. I'd like to quickly establish some webinar parameters before we get started. First, for those that are logged in online, you have the ability to submit written questions to Brian. Feel free to write those questions in the question section of the GoToWebinar console. You don't actually need to wait until the end of this presentation. Go ahead and send those in right away. We'll do our best to have Brian cover as many questions as time permits. Also, somewhat of a change in how we've done things in the past. This webinar, we are inviting those to go ahead and raise your hand. There's an icon on your console that will allow you to raise your hand. And what we're going to try to do is when we see someone raise their hand, we'll pause Brian at an appropriate time and actually allow you to verbally ask questions. We'll unmute your line. Due to time lag in the audio system, we're going to go ahead and ask for your patience, as there is somewhat of a gap. So please be patient. We'll explain who has an open line and who can submit the question or who can speak. Note that any questions that are submitted and are not addressed during today's webinar, Brian has agreed to respond via email to each of you individually. Lastly, Brian's formal white paper and the recording of today's webinar will be available on Friday, September 19th, so look for an email with the respective link from Baroque Tool. All right, with the housekeeping behind us, I'd like to briefly introduce Brian. Brian McConnell was appointed President and Chief Operating Officer of Baroque Tool in 2006. He has over 25 years of HVAC experience, and we're happy to have him here with us today. Without further ado, we'll turn the time over to Brian.
Thank you, Jason. Appreciate those comments. I'd like to kind of set some framework also with the questions. I am more than willing to stop the presentation and pause it to field a question. I think that kind of helps things flow better. And so let's get started. We're here to talk about total cost of ownership. I guess I'd like to start with some general comments of what that means. Obviously, collecting all of the costs associated with a piece of capital equipment is important. There's always a couple obvious ones. Obviously, the price of the machine, it's quantifiable, it's easy to identify. I think the operating costs are the same, but there are a myriad of other costs that are involved in that, and those are the costs that could potentially determine if this was a good purchase decision or if it was a poor purchase decision. So we'd like to explore some of those. Let's see. Baroque Tool is in a unique position in the fact that we purchase machine tools and we also sell machine tools. So we we're on both sides of that coin, and I think it gives us a unique perspective when we start looking at this analysis and justification for purchasing a machine. Let's let's talk about some of those potential other costs. Obviously, we went over. You've got the price of the machine, and you've got some operating cost or maintenance cost. But you also have environmental costs or issues. You've got easy use. We call that the happy operator effect. Making it easier to use, the operator is more productive. You've got productivity improvements just with the machine itself, its abilities and features. Better quality, obviously, can have a positive effect on your operations and downstream processes and the current process. You can reduce the amount of floor space used to manufacture or produce parts. Obviously, floor space can be very expensive in different parts of where, what facility layout you have. And finally, even the cost of recycling, because this machine will have a useful life. At the end, you still need to discard that. So some of these costs, understanding them, quantifying them, it's difficult, but we believe it's absolutely essential to do that to really make an informed decision. So let's pivot a little bit and start talking specifically about the Triumph bender. So we're going to kind of step through some of these things. So let's first talk about productivity, and we'll be more specific talking about cycle time. And if you look at these times, you can see, kind of lay this out. You've got the orange, which is a short, we actually have two lengths of Triumph benders. We've got a short version for making shorter hairpins and a longer feed version, and then we're comparing it to our standard. So let me preference this by stating that the standard hairpin bender, we believe, is as productive, or if not more productive, looking at output per shift than any other machine in the industry. So we think this is a fair comparison, or an appropriate one. So when we look at these times, we want to keep that in mind. So on a meter length machine, you can see that our standard machine, which again we thought was highly productive, you've got a cycle time of 12.8 seconds. The Triumph bender, even if it's a short or a long feed, you got 7.7. That's a 60% improvement in cycle time. Well, obviously that's significant. The 2 meter, you can see they diverge a little bit. Because you have to double, you're going to have to double hitch feed the single, but if you stick with the longer version, again, you've got like a 60% improvement in cycle time, or in the rate. It degrades a little bit when you're talking 3 meter. When you get to the 4 meter, that's actually double. It's 100% more. It's twice as fast as what we're saying is our current, our previous product offering. So at the end of the day, what are we looking at? Well, we're getting more hairpins per shift, which we believe is a good thing. Another leg of that productivity is obviously the number of tubes you can get per cycle. Again, we're going to compare it to our standard, our previous product offering, where we had, if you look to like the 10 millimeter OD, 6 tubes per cycle, and you look at the Triumph bender, now we've got 8 tubes per cycle. Now that is a 33% increase in productivity. There again, as you're measuring, hey, how many hairpins are we going to get per shift or per day? So it's all about, what can we produce? And if we want to look at the length change, so we're changing the length of the hairpin. We're not changing tooling, the diameter, or the bend center. So again, we're going to compare it to our standard offering. It's 20 minutes on average to make a length change. Now, it doesn't take you that long to physically change the machine. However, there are adjustments to be made during that process. You got to check the hairpin, and then you got to move the switch tower or something or the length to get that right. That is not the case with the Triumph bender. It's 30 seconds maximum. And I think if you go look, we have a video on our website I invite you to go check the website, and you can see it. And I think that one's 12 seconds. Now, to be specific, that has a part that's already been programmed. So I'm saying, so if you do that 3 times a day, a shift, or however you want to measure that, there's another hour of production that you're making hairpins. There again, we're adding to that total at the end of the day, how many, or the end of the shift, how many hairpins are we getting out? In keeping with that theme as far as changeover, if you want to look at our standard product offering, on average is about 3 hours to change a diameter change, and typically would also be a center change. You do them together. In the Triumph bender, for various reasons, we've got less tooling. We've also inserted the tooling so you can have tooling set up and inserts so you can change them much quicker. We've got that under an hour. You have to prepare yourself for that. So there again, if you're going to change once a week, there's 2 hours you get back to your week of production. I think also another point to make on this is a lot of companies might dedicate a machine and say, hey, I'm just going to run this diameter and this this bend center. Well, if you reduce your changeover time, now you've got the option to say, hey, can I add flexibility to my processes here, which I believe would lead to more machine utilization. And the next topic is going to be ease of use. So here again, we can kind of put this under the happy operator effect. So if you look at the design of this particular machine, we have eliminated the straightening rollers. Previous offerings, and I think competitors have this series of straightening rollers, and they do require some adjustment, especially if you're going to change tubing, suppliers or coils. You change if you change your OD size, there's quite possibly some adjustments. So we've eliminated those. So hey, we have less parts. So we're using a stretch straightening. So rather than rolling it, we're just grabbing the tube and stretching a little bit. And we believe, and I think we can quantify that they are actually straighter. So there again, we've reduced some of the variation and adjustments in that process, which are again, if you're busy straightening your tubing, you're not running the machine. Another thing we've done with this machine and redesigned is the stripper tubes and end of feed mechanism have been eliminated. Again, we're reducing the number of parts and also reducing the changeover time, and these have been eliminated. And there's a lot of high wear items in their tooling, perishable. Those have been eliminated, again reducing your cost, your operating cost. Now the feed belts, the previous product offering had opposed feed belts that would push the tubing, pull the tubing off the coil and push it through the machine. We have replaced that with a clamped hitch feed, so we're actually physically grabbing the tubing and advancing it forward. So you get no slippage in that process. And we believe that there again, the feed belts are a high wear item. So now you've decreased your consumables and reduced your ongoing operating costs. Again, another one of this operators will be really happy with this. If you have a tube that meets some feeding resistance, and we'll cover this a little later in the webinar as far as small diameter, this becomes very critical. So if your tubes hit some resistance, and if you go talk to your operators or maybe experienced it, okay, the machine shoves it forward, it gets caught in the tooling. What we have is a breakaway system. So you can see we've got a series of guides, these black plastic guides. They're open up top. So when the tube meets resistance, it will come out of that guide. Now at this point, what we have is a way to detect velocity of the tube. So when the velocity of the tube stops, the machine stops. So you're not going to just continually feed this tube, through the machine. It's going to stop and it'll go, oh, we got a problem. So now you haven't engaged the tooling, you don't have this thing twisted up in your machine, it's much easier to clear out. So now what you're doing, if there's a kink in the tube, you're cutting that, clearing it, and relacing. Much easier. There again, instead of clearing tubing out of the machine, you're relacing and you're starting quicker. Again, reducing, making more hairpins per shift. Another advantage is this, we believe, significantly reduces the possibility of damaging tooling. Stripper tubes, feed fingers, booms. This is going to be a much better production environment for your operators. And we're going on the assumption your operators do not particularly like clearing out tubing out of their machine. So let's talk about some of the environmental issues. Look at just flat out per machine power consumption. As you can see, we've got the Triumph at 6 kilowatts as opposed to the hydraulic machine, which was 7.8. We have a question.
Hello?
Hello.
Yes. How does without the straightener rollers, how does that affect tube ovality? Because when you come from level wound product into a tube, sometimes the straightener rollers will help bring the tube into round. Is that affected any with the new bender?
Okay. Let me repeat the question so everybody could hear that. The question is okay, you've got the straightening rollers, and we removed those, and now we're using stretch straightening. How does that affect the ovality of the tube, which means when you put them in the coiled form, they tend to deform a little bit. Well, in this application, you can see it's overhead on coilers, so there's less deterioration of the tube ovality. But we do have sizing rollers. So we have kept the sizing rollers. So we're kind of resizing a little bit. Does that answer your question?
Yeah, I guess the only other thing would be what type of percentage ovality can be achieved, just pretty much the same as with a regular bender.
Yes, let me repeat the question again. So we're kind of comparing and contrasting the percent of ovality back to the current hydraulic bender, and yes, we're getting similar, if not better, results in the output that we're getting from the stretch straight.
Okay, that answers it.
Okay, thank you. All right, so we decided, hey, well, look, we got some power consumption reduction in this machine, which makes sense. You've got a hydraulic unit, a motor, and that has been eliminated. But now let's compare and contrast it. That's per machine. Now I think we went over with some of our productivity numbers. We're looking at, if you look at 70% increase in cycle speed, the 30% increase in number of tubes, and then we've got the easy use, so this thing's running more. Our opinion is it's very easy. Look, that's almost a 2-to-1 there. So now I could have one machine producing the same as two. I've removed one. So if you look at that, now I'm seriously cutting our power requirement down. I think that's another thing to kind of look at. The other environmental issue was almost every coil shop I've been in, if you walk up to the benders, whoever they are, the hydraulics, whether it's ours or somebody else's, there's always a pan underneath the machine collecting all the hydraulic fluid. And what we're saying, we don't have that now. It's more of electric, so you don't have that mess. So you've got safety concerns, you're using less oil dry, you've got less cleaning. Yeah. Okay, let's look at we're getting down to kind of one of those more obvious factors and saying, okay, how much? It always comes down to how much. So we're looking at the initial investment. If you look at it, we've reduced the capital cost of this machine as compared to our previous product offering. And we've done that really in a couple different ways. One is we only have two links. We mentioned earlier, we had a long and a short. Previously, I think we had 6 or 7 different lengths. So we've modularized this thing, which makes our production, making parts a little easier. And it also, we really have 2 different frames. We've got the front end that does the cutting. That remains the same for both lengths. So that's allowed us to improve our manufacturing capabilities. Now, this also has allowed us to make stock machines. We have stock machines, and obviously the lead time in taking the tooling out, we'll still have to make tooling specific to your applications, but I'll have the machine itself potentially on the floor. Couldn't really do that effectively with our previous design. And we've removed a lot of parts. Okay, let's turn a little bit. Let's talk about that footprint, because previously we mentioned floor space consumption. If you look at the overall footprint of the 2 machines, we have a 30% savings in floor space per machine. Again, this could be just like the power consumption, but you've also potentially eliminated 1 machine and got the same or more hairpins per shift. So there again, now I don't know exactly if we have a specific number, or if you do in your organizations, of how much does a square foot or a square meter of floor space cost you, or what's the value of that. But I believe when you're looking at this purchase decision, that's a good thing to know and identify. So we kind of want to put that in front of you. In improved quality, let's go over some of that. Let's talk about a little bit about the process. This machine's process is different. And again, there's a video on our website, and I invite you to look at that video. We've really changed things around. So if you look at the bending process, we have a leg of the hairpin in the boom, and it's clamped. And then we bend the tubing. Now the other leg's free to move, but it hasn't been cut yet. So after that bend, we advance the tubing forward, then cut it. What we've done really is we've eliminated or reduced a lot of that variation in the bending process, because now we haven't cut yet. Now that variation happens, then we cut. So what we found is that the overall leg length is much more accurate. Now that obviously will have benefit effects downstream process for expansion. And I guess I'd like to tell a little story about the improved CPK. And that's, just statistical measurement process by which we measure hairpins and other components. When we were developing this machine, we put it on a customer's floor, and we asked them to run it. And they ran it for 3 or 4 months. And this was an organization that didn't make coils, but they provided hairpins to other customers that made coils. And they also provide, when they ship those hairpins, statistical information, CPK, to the end user. And they started using our Triumph bender, and they sent the hairpins and the information. Got a call back from the end user saying, something's not right. This is not right. These numbers, you got something wrong with your data or your analysis. So there again, the customer was using the machine, sent the raw data, sent it to them. They did their analysis, and sure enough, it was right. The customer could not believe that it was getting such a large CPK number. But then we proved it. So that has downstream effects, positive effects on your downstream processing and better quality. Let's go back and talk about the stretch straightening a little bit, removing the straightener rollers. We believe that it actually gets the tube straighter. So we believe it improves your lacing with a straighter tube. It's easier to lace fins, especially critical with small diameter coils. And another positive effect is we believe it reduces work hardening on the tube, or it's certainly more consistent. When you're straightening material, you're only moving part of it and working part of the material. We are stretching that whole tube. So we believe that we've got a more consistent, we have less work hardening and the tube's more consistent, which also would help you in your expansion process. Anytime you can reduce variation in your process, no matter how small, we believe it's a benefit. Okay, so let's talk a little bit about manufacturing aluminum tube coils. That's kind of in the last 4 or 5 years been a new effort in our industry to go away from copper and into aluminum. And we believe that given the way the aluminum tube is manufactured in an extruded process, that really the only way to effectively straighten those is not with rollers, because that really requires a lot of adjustment and tweaking it in. If you can get it, we believe stretch straightening is the way to go. So if you're going to make aluminum hairpins, we believe that stretch straightening is absolutely necessary. So let's talk about, so we also have that different feeding mechanism. So we went away from the belts, and we've got this clamping hitch feed, moving it forward. If I take you back to processing an aluminum tube with belts, it's friction. The belt grabs this tube and feeds it forward. Well, you do get slippage. And there is lubrication potentially on that tube, certainly oxide, aluminum oxide, which is the same thing we make grinding wheels out of. That's a very abrasive substance that's coming off there. High wear on the belts. In fact, what happens is you build it up and you get more slippage and it's harder to feed the tubes through. Typically, what we see in the industry using the old style belt is if they have a 6-strand machine, have 6 tubes at a time, only running 4, because that's physically what the machine can do. Now you can change the belts, you can retool it, clean everything, and get 6 for a while, but you're going back to 4. And that's really what we've experienced. Now you compare that to the Triumph bender. Well, now we've got this clamping mechanism and hitch feeding, and I got 8. So we've gone from 4 to 8. Now you've got also the cycle rate, productivity, and all these improvements. We have received communication from users that it's a 3-to-1. We can produce 3 times the amount of hairpins on this machine making aluminum than we can our standard product offerings or other similar type feeds. There again, that's going to make the effect of floor space, power consumption, all a little bit better. I mentioned it previously in the presentation about smaller tube coils. So let's talk a little bit about that. One of the problems, obviously things become a lot more critical when you're looking at smaller tubes. Everything has to be just so. And if you look at their old feeding mechanism again, we're taking this belt, grabbing it around the tube, which is not as big now, so it's harder to get a hold of. There's less contact. It's harder to feed. So that's been reduced. The integrity of this is the durability or the columnar strength of this tube is significantly less than a 3/8. And let me go back. Specifically, we're talking 5 and 7 millimeter. That's where we're defining a small diameter. So we've got a better feeding mechanism. We're grabbing the tube with a smooth bore clamp, and we're advancing it forward. And smaller tubes will tend to jam up more. If there's a kink, smaller kink will produce a problem, right? So because you don't have the columnar strength. So this breakaway system gets even more critical and important to your operation. As I mentioned previously, redesigned the tooling. So you've got the mandrel is really encased in the boom. So it's really supported. So even if you do get some resistance, you're not going to bend that mandrel. Now in the previous, if you had resistance, that mandrel wads up. Now you're cutting the mandrel out and replacing that mandrel. So again, we've reduced the operating cost because that's a lot less likely to happen. So we believe that put all these things together, it's very important and critical when you're doing smaller diameter production, tube production. So let's pivot back and kind of go over this again. So there's a lot of different factors in making this decision. Obviously, you've got the number of tubes per cycle. You've got the cycle rate. You've got power consumption, floor space utilization. maintenance cost or operating costs, replacement parts costs, operator labor costs, changeover times, quality, overall uptime, and recycling after the useful life of the machine. So this is this is kind of what we believe an all-encompassing look. That's total cost of ownership. So we believe it's to put that all in the equation and see what it kind of gives you. So you look at, we're here talking about the Triumph bender. Let's look at that. Now, clearly the Triumph bender, I think we've proven it's faster, you get better quality. Those are important things, but at the end of the day, we're talking about a return on your investment. So let's try to quantify that and make it as clear as possible. So again, we think it's critical to have all this in your analysis. And we do this for the Triumph bender. We believe it's a very clear return when you look at its cost of ownership numbers and an exceptional one. So let's go through this. We've got a calculator. We're calling this a calculator. So on the front part, we've kind of covered the top part, right? Top three. I said, okay, there's we've got 8 tubes per cycle, and we've picked a couple of different competitors, and gotten some market information, price and productivity, and if you look, you can see that obviously the number of hairpins that you're getting on an annual basis is higher. So in the middle section there, hairpins per square years, and then the comparison. You can see we're sitting at 220% of competitor B, which is kind of the lower priced option. And we've got another competitor that's more comparable as far as our machine, and we've got still, they're 130% of that competitor B, we're at 220%. Again, at the end of the day, we're talking about, wow, I'm getting all these hairpins per shift or per day or per year. Let's talk about the price. So we're kind of setting this and saying, okay, we're kind of setting the bar here. Here's $1, and we can go buy a machine that's 80% of that. We believe, we're going over all this. The operating costs are going to be 8 to 10 times ours because there's tooling and uptime and all that. You go to the less expensive machine, the cheaper machine. Well, that kind of ramps up a little bit. So you got 18 to 20%. So we're trying to get down to how much does it cost me per hairpin. We think that's a very basic and easily understandable. So if you look at that, we're saying, hey, look, at ours, it costs you $1. You got $1.08, $1.08, and 2.1 for the cheap. So I think we're demonstrating is, yeah, okay, we can look at the machine price. I understand capital is important, but it might be a very expensive option looking for lost opportunities. Now we have this calculator. Anybody that wants to talk to an Oak sales engineer, we can sit down and go through this, go through the assumptions, look at your production requirements, and we can use this calculator and come up with some of this information. And I think we can get you a very solid, objective, here's what we think it is. Now clearly that would be a conversation we would love to have with you. Well, that's about it for my presentation or the webinar. I thank everybody for joining and listening to my comments. Are there any questions?
Great, thanks, Brian. So again, just to reiterate, those that have jumped online, feel free to submit written questions if you don't feel comfortable, as well as go ahead and raise your hand. There's icons of buttons that you can use to indicate to us that you'd like to ask Brian a question. So. Okay, so far, again, if there are any questions that you think of as we're departing, feel free to submit those and even send an email to marketing@baroque.com, and we can facilitate the answer to those questions. A couple closing points of note. Over the next few weeks, Brian will actually respond to those questions that you might still have. Another comment is our new website, which is scheduled to be complete this fall, will actually include some evaluative tools and calculators such as you've actually seen today. Brian referenced the calculator. Our goal is to have a do-it-yourself online that would enable you to be able to insert your own data points, make a unique customized analysis for your organization. Again, that's going to be available in our new website later this fall. Another thing that we'd like to point out, we're always trying to improve everything that we do. So if you have any points of feedback for us, it could be webinar topic you'd like to hear about next, what specific machine of ours could use an improved variable set of anything, from the feed coil or the feed system all the way up to the end of production, as well as ways we can make our relationship with your relationship with Baroque Tool better. Please submit that to feedback.baroque.com. You're looking at the slide. That will be a permanent website of ours, so again, if there's anything after we close the webinar, if there's anything that comes to mind, that's a permanent website that will allow us to provide feedback. If you'd like to leave it anonymously, we're leaving that as an option, such that if it's something you believe is sensitive and you don't want to be pointed out, your operators can also have an opportunity to do that without being identified by Baroque Tool. And again, that's everything from how our communication channels could be better, the frequency of communications, even up to the end-to-end buying process you might have. So I suppose if there's no other questions, I haven't had any written questions or anything else come in, I think we can say thank you for your time and enjoy the rest of your week. Thank you, everyone.